This is AP Chemistry topic 3.5, kinetic molecular theory. So the kinetic molecular theory says several things about gas particles. And this is not the theory in itself, but I'm pulling out the important features here. So it says that gas particles are in constant motion, that they fill the container, that they have no volume, that they create pressure by colliding with the laws of the container, that they have no intermolecular forces, that they have elastic collisions, meaning all of the energy that goes in as motion comes back out as motion, and that kinetic energy is directly proportional to Kelvin temperature. So if we look at how we might draw this with a particle diagram, one way we draw this is by using arrows to represent movement. And so your arrows would be longer with a higher temperature, and they would be shorter with a lower temperature. Also notice that the particles are spread out in the box, and we can see this down here. If we're comparing situations of higher pressure and lower pressure, we would want a higher pressure to look like this with more particles, whereas a lower pressure would look like this with less particles. We would not have it sitting in one area of the box. Remember, it would fill the box because that's what gas particles do. So then if kinetic energy is equal to 1/2 mv squared, then we know that if your temperature is the same, your kinetic energy is the same. Now that does not mean that the velocity or speed is the same. That is proportional to your mass, which you can see on this equation, which is found on the equation sheet. So looking at this, if your mass goes up, then your your velocity must go down. So we can look at this in terms of two different graphs, this equation. So first of all, if this is the percent of molecules or the fraction of molecules or whatever you want to say, as your temperature increases, your velocity would increase for the molecules or the particles. Now, I do want to point this out. This graph is a little bit different than most graphs you're used to. You might think that you would be choosing this graph for the higher temperature for particles going faster, but you're not, because what you're looking at here is the percent or the fraction of molecules or particles. And so what I want you to think about here is the area under the curve. More particles are at a faster velocity at the higher temperature, and that is what we're representing here. And then similarly over here, if we're comparing molar masses, we can see that the smaller, less massive particles have faster velocity. And again, that's related to this equation up here. So the less massive they are, the greater the velocity. And so we can see if we compare noble gases here, that as we move down the periodic table and your noble gases get more massive, they also have a smaller average velocity. So that's it. Let me know if you have questions.